Okay, so going to look at question 1 from the moles section. It's asking us to look at or calculate in the first instance, the relative formula mass for carbon dioxide. So it gives us the formula of carbon dioxide, and we know from that there is one carbon atom, and then there are also two oxygen atoms within the molecule, the CO2 section. And so the relative formula mass is an addition of the relative atomic masses that are in the compound. And so if we know that there is one carbon atom and a carbon atom weighs 12, you'll be given the number in the question, then we've got one lot of 12 within the molecule, and we know we've got two oxygens. We have two lots of 16. That two lots of 16 obviously equals 32. Add that to the 12 from the carbon, and we get a molecular mass of 44 for carbon dioxide. We can then use that to go into the subsequent question, which is asking us to calculate the number of moles in 110 grams of carbon dioxide. So obviously they have given us the mass of the compound, which is 110 grams. They're asking us to calculate the number of moles. And the number of moles of a substance, we have to memorize this equation, and the number of moles is equal to the mass divided by the MR, as we're given in this question. And so we know that the mass of carbon dioxide is 110. We've been given that there. And we know the molecular mass of carbon dioxide is 44, because we calculated that in the previous question. You would get error carried forward for these types of questions, should you make a mistake on the molecular mass. And so once we do that, we calculate that value, and for this one, we get a value of 2.5 moles. So there are 2.5 moles of carbon dioxide in 110 grams. And so if we then quickly just move on to the third question, we'll just get rid of that bit out of the way. And it's asking us to answer which would weigh more, 1 mole of carbon dioxide. So we already know the mass of 1 mole of carbon dioxide, because that's essentially what the molecular mass is. And so we know that carbon dioxide weighs 44. And it's asking us to compare that to 1 mole of carbon monoxide. Now, using the naming of the compounds, we know that this is going to have 2 oxygens within the molecule. This is only going to have 1 oxygen within the molecule. And so that's going to be carbon with 1 oxygen, which is going to have a mass of 12 again for carbon. Again, just on top of the page. Oxygen going to have a mass of 16. And we add those two numbers together this time. That gives us a molecular mass for carbon monoxide of just 28. And so if we were to weigh out 1 mole of that, that would be 28 grams. Carbon dioxide would be 44 grams. And so which would weigh more? In answer to the question, carbon dioxide would weigh more. It's got more stuff in it. It's got 2 oxygens, so we could have worked it out just from the naming of the compounds. But in calculating RFMs, carbon dioxide has an RFM and hence a mass of 44 grams for 1 mole. Carbon monoxide has an RFM of 28 and hence 28 grams for 1 mole. So carbon dioxide would weigh more.